16th. Oh, sorry, 16th. Today is 16th. And we're looking at sets. Practical applications. We will go straight ahead to look at what is called the complement. The complement of a set. What is the complement of a set? There are different definitions to this, but I'll give you one that is very simple. The complement of a set represents elements that are not in that set. The complements of a set represent elements that are not in that set. For instance, if I have a set A and I have 1, 2, 3, 4, maybe I should add at this point that the complement of the set must be defined with the knowledge of the universal sets. I'll come again. The complement of any set is defined with the understanding of the universal set. So I can't define the complement of a set if I do not know its universal set. So for this question, the universal set was defined as 1, 2, 3, 4, 5, and 6. So very clearly, the complement of a set A with a prime, sometimes you hear the word A prime will now be the elements that are not in A but are in the universal set. If you look at this, I have 1, I have 2, I have 3, I have 4, I have 4 here, but I don't have 5 and 6. So the complement of that set, which is treated as A prime, will now be what? 1, will now be what? 5 and 6. So the complement of the set A is what? 5 and 6, representing elements that are not present in the set. So diagrammatically, how do we represent the complement of a set? If this is a set, now let's listen attentively. As a rule in sets, the square is usually used to represent, the square or rectangle is used to represent the universal set. The square or the rectangle is used to represent the universal set. And the set described must be in the universal set. So this is A, for instance. So this region here that is inside the universal set but not in A is where we call our A prime. So I'm going to shade that for better clarity of our work. So the area I have shaded is called A prime, where A prime is the complement of A. So A prime is the complement of A. This is the universal set represented by, so anytime in set you see a rectangle or a square, you are talking about the universal set. But when you see a circle, an ellipse, you are talking about the set in question. The space occupied between that is not in A is treated as the prime. So another description for complement of a set is A prime. So you hear students say A prime, B prime. In set, it means the complement of a set. I hope that point is well passed. And to further drive home what we are teaching today, I want us to go to exercise 8B. Exercise 8B. I'll do a few examples there, and I will trust that that would help make our understanding very great. So before I continue, to do question number 1, exercise 8B, question number 1. So Try your hands on the questions. I'm going to solve along with you, but just try your hands on the questions. Let's see how it goes. Try your hands on the questions. Exercise 8B, question 1. Getting this done. So I'm going to be looking at exercise 8B, question number 1. It says, write down the complements of the following. Write down the complements of the following. Remember, we said that the universal set is only defined, the complement of a set is only defined with good knowledge of the universal set. So the universal set in this question is given as what? 1, 2, 3, 4, 5, 6 rather, and 8. Now, number A, you say, what's the complement of that set? The complement will be what? The complement will be what? 4, 6, and 8. The elements that are not there. B, what's the complement? So you should tag it, just say complements. Complements of set below. Complements of set below. A will be what? Will be what? 4, 6, and 8. B will be what? What is B? B will be, I can't see 1, I can't see 2, and I can't see 3. So that's the complement. Then C, I cannot see what? 1, I can't see 3, I can't see 6, and I cannot see 8. Okay, I'm not going to do all, but let me just pick some. Now look at this. Now, the next one, G, I don't know if you have seen this symbol before. This symbol means null or empty set. It means what? Null or what? Empty set. Null or empty set. Null or empty set. That's what this symbol means. So, it means that this set, this is what it means. That there's no element in it. What is the complement of not seeing anything? It means I will see everything. The complement of not seeing anything is seeing what? Everything. So it will be this. It will be this. 1, 2, 3, 4, 5, and 6 rather, and 8. So that's what that will be. So that's what that will be. So that's what that will be. All right. So what it means from here now is that the complement, look at it, the complement of an empty set is the universal set. So take note of that. The complement of an empty set is the universal set. The complement of an empty set is the universal set. That's a very important knowledge you need to have. Now, it therefore means that the complement of the universal set is an empty set. So by implication, the complement is, watch that, the complement of the universal set is actually an empty set, or this. So the complement of this set is this, the universal set. So take note of that. The complement of the universal set is an empty set. The complement of an empty set is the universal set. All right. 2. Now, in question number 2, we are given the universal sets. This one is quite interesting now. We are told it's in letters A, B, C, V, and E. Added to that, we have that A is A, C, E. Hope I'm right on that. And B is what? B, E. Now, these are the set description given to us, and we are told to look for A prime. So I'll make it an exercise. I think everybody should be able to do this. Now, let every one of us give me A prime. You can just drop your answer on chat. A prime. Give me B prime. So let me have A prime and B prime. Could I get answers to that? The universal set is given as 1, 2, 3, 4, 5. Now you see 3 dots, and then you have 10. It means that the number continues to, you continue in that manner. You continue in that manner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. The question says A is giving us this 1, 2, 5, 7, and B is giving us now. It says we should write down. This is what you're going to do for me. Say write down the sets A prime. So do that for me. A prime, B prime. What is A prime? What is B prime? What is A? Now, do for me. What is A prime? What is B prime? What is A union B? Do that. And then do what is A union B or prime. Now, these are the questions I want you to do now. Do A intersection B. And then tell me what is A intersection B or prime. So let's have these answers quickly posted by chat. So let's do that and post them by chat. Waiting for your response. A is 1, 2, 5, 7. What then is A prime? A prime is elements that are in the universal set that are not in A. So I'm seeing 1, I'm seeing 2. That means there's no 3. I can't see 4. I can see 5. There's no 6. I can see 7, 8. I can't see 8. I can't see 9. I can't see 10. So that is A prime. Now we have B. What is B? B essentially is what? 1, 3, 6, and 7. 1, 3, 6, and 7. And B prime will now be 1, will now be 2. I can't see 2. I can't see 4. I cannot see 5. I can't see 8. I can't see 9. And I can't see 10. So what is now A union B? Because you can't get A union B prime without considering A union B first. What is A union B? A union B will be equal to all the elements that are A and B. So I am seeing 1, I can see 2, I can see 3, I can see 5, I can see 6, oh sorry, I can see 7. That's not it. A union B. Okay, I can see 1, 2, 6, 5, 6. I can see 7. So you have lots of elements that are common. 1, 2, 3, 4, 2, and 5. We won't come. All right. So that's A union B. So what is now A? What then is A intersection? I mean A union B or prime? A union B or prime. What would that be? It will mean all elements that are not in A and B. So we take that. I can't see 4. I can't see 6. I cannot see 8. I can't see 9. And I can't see 10. All right. So what's the next one you're going to look for? You look for A intersection B. What is A intersection B? We look for the elements that are common to A and B. If you check very well, the elements that are common to A and B are 1 and 7. 1 and 7. You can double confirm these answers when you're doing your work. Look at it. 1, 7. So 1 and 7 are common to that. So A intersection B or prime will be 8 other elements. 2, 3, 4, 5, 6, 8, 9, and 10. So that's that. That's that for elements that are all right. So that's the scope of our work today. But before we go, I'll need to take the attendance because I've seen some names that. So I'm going to